This question is asking for the circuit in figure P7.136 called a bootstrapped follower. In this video I'm just going to do the A part. In my next coming video I will do the B part, C part. Okay, the A part of the question is asking find the DC emitter current and GM, RE and R phi use beta is equal to 100. Okay, so when it's DC, what we do is we neglect this the part with capacitors. So this one is gonna act like a open circuit. Let me double check. Open circuit or shorts open. Yeah, open circuit. Open circuit means the path has been opened. So this one act like a open circuit. So it means we have to, the equivalent circuit is going to be look like this. Okay, we are drawing this 20 ohm resistor. And the bottom part of it is connected to the ground. This is 20k, and we are getting rid of this. This is also open circuit, whatever the capacitor has. So it's gonna be like a series with the base right here. So the 10k ohm resistor over there is a series with like this. Okay, and this bottom part is connected to the ground, and here we have a 2k ohm resistance. And what else we have? We have this 9 voltage here, exact voltage right here as well. So these both of them plus 9 voltage, plus 9 voltage. Other than that, nothing else to worry here. So this is the circuit, equivalent circuit, and we can simplify this circuit, but we can simplify this circuit furthermore by using Thevenin's theorem. Okay, let's see how it's going to look like. So if we apply Thevenin, what we do is we combine the voltage here is going to be this voltage VB, and this ground is we combine them together and call it as V Thevenin, and then equivalent resistance is going to be R Thevenin. So if we do that, then this resistor, whatever the resistor here on top, divided by addition of these two resistors, multiplied by 9, that's going to be the V Thevenin. V Thevenin is equal to 9 times 20k over 20k plus 20k in this case. And the R Thevenin is going to be the resistor that's parallel. So 20k parallel 20k. So if you calculate this, you're going to end up getting V Thevenin to be 4.5 voltage, and you get R Thevenin to be 10k ohm resistance. This is, if it's parallel, that's product over sum. So 20 times 2400 divided by 40, that is 10k ohm resistors. So now we can draw the equivalent circuit. The equivalent circuit is just gonna look like this. We are gonna have the whole thing replaced with the voltage right here. That is gonna have minus plus like this, and this is R Thevenin, which is equal to 4.5 voltage, and here this is V Thevenin. V Thevenin 4.5 voltage, and here we have R Thevenin, that is 10k ohm resistance, but here we still have another resistor at the base, that will still come there, and others remain the same. We just simplify the inside of it. So top is going to be 9 voltage, and then bottom connected with the 2K, and then grounded. Okay, this is the resistor we have. I mean, this is the circuit we have. Now we consider this one as a loop, and we can solve for something we need to know. Here they are asking us to find out GM, RE, R5, all these things. Now in order to calculate the GM is given by IC divided by VT. Okay, and here this is base. Like if we do the KVL, we can find the base current. At the same time, we can find the emitter current as well. If we find both of the current, that will allow us to find out. Actually, if we find the emitter current, that will allow us to find out the collector current, because that's what we needed for GM, to calculate GM. Let's look at it in the next page. First, I write the equation for GM. GM is equal to IC divided by VT. Okay, VT is nothing but 26 millivoltage. That's thermal voltage, so we don't have to worry about that. That is a constant value, same for everywhere. IC is what we have to calculate. Okay, IC is what we have to calculate. So if I apply KVL here, KVL says VThevenin minus all the other voltage should be equal to 0. Initially we have this voltage minus all the others should be 0. So we can also say this VThevenin also equal to all the other voltages. So here if we look at 10K, that forms 20K, because these two are in series. 20K times the current over there, that is, you can say IB, or if you want to express in terms of IE, you can say IE over 1 plus beta, because IB is equal to IE over 1 plus beta. So we can put this one as well. And then at here we have a VBE. This one right here is VBE. So that will come here. And after that we have this 2K, and this is emitter current over here, IE. Okay, so plus 2K times IE. That is it. Now what else? What do we have available? And writing in terms of IE for the IB help us, because when we do that, we only have one unknown variable. Then only we can solve it. Otherwise, it's hard to solve. Now VThevenin is available to us. That's 4.5, and then this is 20K. IE is unknown, and then 1 plus beta. Beta is given in the question. That is 100. Plug that one in here. And VB is 0.7. VB is 0.7 for silicon transistor. If it's germanium, 0.3. But if it's not mentioned, it's silicon, because germanium is a rare case. So it is a silicon, 0.7 all the time. So when the question don't mention germanium, it's always 0.7. So this is 0.7 right here, and then 2K times IE. So here we have only one unknown variable. We have to just rearrange and solve for IE, and if you do that, you will end up getting 1.73 milliampere for the IE current. Now in order to calculate GM, we need IC. We have IE available, but we need the IC in order to calculate that. And the relation between IE and IC is IC is basically beta over 1 plus beta times IE. So if you plug the values, that is 100 over 1 plus 100 times IE, that is 1.73 milli. And if we calculate that, we will end up getting 1.71 milli for IC. So now we have IC, and Vt is a constant value, that is 26 milli. So gm therefore 1.71 milli over 26 milli, and if you calculate gm, you will end up getting 68.5 milli voltage. Milliampere per voltage. Okay, so this is it for this one. Now the next thing, what else we have to find? We have to find emitter resistance and also the R5. R5 also equal to RB. You can call it as RB as well, but that is the case right here, so we can calculate both of them. First, if we start with calculating R5, R5 is nothing but beta over GM, and beta is available to us, that is 100, and GM is available to us, that is 68.5 milli. And if you calculate this, you are going to end up getting 1.46 kilo ohm resistance. And the next one we have to calculate is RE, the emitter resistance, that is VT, the thermal voltage, thermal voltage over the emitter current, and thermal voltage is 26 millivoltage, and then IE emitter current, we calculated that one to be 1.73 milli. Plug that in, you will end up getting 14.5 ohm resistance. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.